In this video, we're going to review solving a quadratic by completing the square. The very first step for completing the square is going to be to take the entire equation and divide by the a value, which in this case is 2. And if I divide the left-hand side by 2, I need to divide the right-hand side by 2 as well. And that's going to give me x squared plus 6x plus 5 over 2, and that's going to equal 0. The next thing I'm going to want to do is move this c value to the other side. So I'm going to subtract 5 over 2 from both sides. And I've left a space here because I'm going to need to fill in something on both sides in order to be able to complete the square. And the way I determine what I want to fill in on both sides is I come over here, so I'm thinking about my little thought bubble, and I'm going to take b and divide it by 2. In this case that gives me 3, and then we square that. So b divided by 2 squared is 9, so I'm going to add 9 to both sides of my equation. Once I do that, I've forced this polynomial on the left-hand side, this trinomial, to be a perfect square trinomial. And what that means is that when I factor it, I can get it down to just this one little set of parentheses squared. And the way that this factors out is we can take the square root of the first term, x squared, and that's going to give us x. Take the square root of 9, that gives us 3. And then I take a look at whatever symbol is here in front of the b, and that's going to be the sign inside my parentheses. So x squared plus 6x plus 9 is really equivalent to the quantity x plus 3 squared. On the other side, I need to combine like terms here, and in order to do that, I want to make sure that my fractions have the same denominator. So in this case, to make 9 have a denominator of 2, I can multiply by a fancy one of 2 over 2. 9 times 2 is 18, and the 2 stays on the bottom. So that's going to give us the quantity x plus 3 squared equals, and if I combine these two, remember we combine the numerators, and we're going to get 13, and we keep the denominators the same. So we get 13 over 2. So we have x plus 3 squared equals 13 over 2. The next step is going to be to take the square root of both sides so that I can unsquare it and get x by itself. So we have x plus 3 equals, and whenever we take the square root of something that has an x squared in it, we generate a plus or a minus. So I have plus or minus the square root of 13 over 2 on the right hand side. I'm going to want to move the 3 to the other side to get x by itself, and when I do that, I'm going to write the negative 3 before the plus or the minus. It's simply conventional to do it that way. It's not incorrect if you do it the other way, but we want to do things conventionally. And we still have the square root of 13 over 2 here. The only problem now is that this is not rationalized. We have a radical in the denominator because the square root of 13 over 2 is the same thing as the square root of 13 over the square root of 2, and that's not allowed. So to rationalize, if you remember, we are going to take our fraction and we're going to multiply by a fancy 1 that comes from the denominator. So I'm going to multiply by the square root of 2 over 2. So that's going to give me x equals negative 3 plus or minus 2 times 13 is 26, so I get the square root of 26 over the square root of 2 over 2 is a plain old 2. And so my two solutions are negative 3 plus or minus the square root of 26 over 2.